These last two topics should be quick, so I'm going to go ahead and put these in one video. We've got similar triangles for our first topic. These will be our purple background. And then when we get to the yellow, we're looking at special right triangles. So similar triangles, remember, have proportional sides. So if triangle AB, sorry, that's a typo there, that should be C. Triangle ABC is similar to triangle DEF. Their sides have the same proportion. So to solve for x, we could set up side AB with DE, setting up a ratio, which means side x would go with side EF. To solve, you can either cross multiply, or to solve for x, I'm just going to multiply both sides by 3, and 9/2 equals x, or you can put that into a decimal if you prefer. We don't have any labels, so it would just be 4.5 units. Same thing to solve for y. So 3/2 would equal 4 over y. Make sure you start in the same triangle for both of your ratios. So I started in triangle ABC every time. To solve for y, you can cross multiply, or you can flip your ratios to make y in the numerator instead of the denominator, and then multiply both sides by 4. So we get y equals 8/3, or you can turn it into 2 2/3, if that makes more sense to you for the length of the side. This one is setting up a word problem. So we've got Jason standing 3 feet from a mirror. So here's Jason, he is 3 feet away from the mirror. And he saw the top of the head of his partner in the reflection, who was 3.5 feet away from the mirror. So here's his partner. If Jason is 5.5 feet tall, how tall is his partner? So if we think about making similar triangles with our two people and their distance from the mirror, we can set up another proportion. So we have Jason's height, 5.5 feet, so I'm going to convert that to a decimal, is to 3 feet. You can also, when you set up your proportions, stay in the same triangle. And then we would have x, the height of his partner, over 3.5, the distance he is from the mirror. Multiplying both sides by 3.5 to solve for x. And dividing by 3 to make it make sense, we get 6.416 repeating feet. But we never talk about somebody's height as a decimal. We would convert that to inches. So to convert the 0.416 repeating to inches, there are 12 inches in a foot, so you would just multiply by 12, and we would get 6 feet 5 inches is the height of his partner. Last topic, we're on special right triangles. So remember that in a 45, 45, 90, the two legs are the same, and the hypotenuse is in a ratio of times the square root of 2. For 30, 90, 60, and I talked about this when we went over the MCA prep, I write this out of order because across from the 30 is the 1, across from the 90 is the 2, and across from the 60 is x times the square root of 3. So if you remember 30, 90, 60, you just need to remember 1, 2, square root of 3 to get the correct ratio. All right, so here we're told they're both special right triangles, 45, 45, 90. So we've got these congruent angles here, which means they're isosceles, so the legs are the same. And then the hypotenuse for this one, you take the leg and multiply by the square root of 2. For part B, we know the hypotenuse. So I'm going to set 12 equal to x times the square root of 2 to solve for the length of each leg. Dividing by the square root of 2. Rationalizing, I need to multiply by the square root of 2 over the square root of 2, which in the denominator, the square root of 2 squared is 2, and then 12 divided by 2 equals 6. So each leg is 6 times the square root of 2. And finally, let's take a look at our 30, 90, 60s. So for the 30, 90, 60, remember we have x, 2x, x times the square root of 3. So in part A, we know the side across from the 90, so that is our 2x. Solving for x, we get 2.5, which is the side across from the 30. And then the side across from the 60 would just multiply by the square root of 3. And part B, last example, we know the side this time across from the 60. So we set the 14 equal to x times the square root of 3, the ratio of the side across from the 60-degree angle, dividing both sides by the square root of 3, rationalizing by multiplying by the square root of 3 over the square root of 3, and in the denominator, that square root of 3 squared simplifies to 3, and 14 doesn't simplify with 3, so that is our x. That is the side across from the 30. To get the side across from the 90, we multiply that by 2.